Right, good morning Year 9. So today we are looking at ionic compounds. It's quite a short video today, you'll be pleased to hear, and then you've got some exam questions to have a go at. I feel like I've given you quite a bit of work over the last few days, so just a little bit of a quick one because it's quite a quick topic. So ionic compounds, last lesson we looked at how we form ionic bonds. So we looked at metals lose electrons to become positive ions, and we looked at the fact that non-metals gain electrons to become negative ions. I then mentioned something called electrostatic attraction. So when we have a positive ion, which is a metal, and a negative ion, which is a non-metal, we have this invisible force of attraction. That's known as electrostatic attraction. We've come across this word before when we looked at positives and negatives, when we looked at the structure of the atom in terms of protons and electrons, and I've talked about it in reflection of magnets as well. So electrostatic attraction is that force of attraction between oppositely charged particles. It's actually very, very strong. Okay, so it's really important whenever I teach my GCSE groups, I always tell them to say electrostatic attraction, which is very strong, and learn that as a sentence, because then whenever you write your answer down and you write electrostatic attraction, you then write which is very strong, and usually those two things are worth two separate marks. So just electrostatic attraction, which is very strong. So when we look at ionic compounds, we don't just have one sodium atom and one chlorine atom, for example. What we have is we have lots of them. So this positive will attract a negative and another negative, which will then attract a positive, which then in turn attracts another negative. So what happens is we start to build up this big bunch of lots of oppositely charged atoms. And that's what we get, well, that's what is known as an ionic compound. They are sometimes called ionic lattices because they are big crystal-shaped structures. So you might sometimes see them referred to as ionic compounds, sometimes giant ionic structures, and sometimes referred to as ionic lattices. All of them mean the same thing. It means that we've got lots and lots of positives and negatives all built up together, held together by this invisible glue, which is the electrostatic attraction. So there are three models that you can be given in your exam and be expected to be able to analyse or work out. So for example, here we've got a 2D model. The 2D model, the benefits are you can see the repeating pattern, but the negatives, it doesn't show that we've got any layers. It just shows that we've got one thin layer of positives and negatives. We then have a 3D model. Now I'm really sorry, my drawing ability is abysmal, as my class know. So bear with me on this. If you want to Google 3D model of ionic compound, you're probably going to get a better picture. But you get the idea, it's a cube shape. So we get our 3D model. So the benefit of this is that we get our repeating pattern again, but we also this time get shown the layers, that it's not just one layer thick, it goes back and down as well. The negatives of this model are quite often it shows the same charge of ion next to each other. So if you look here, for example, this row's going back and this row's going along the front of the cube, if you imagine a cube. And we've actually got two negatives next to each other here. Here we've got two positives, so we've got lots of positives there, lots of negatives there. So what's one of the negatives of the 3D model is that quite often it shows positives and positives or negatives and negatives next to each other, which is wrong. The other thing to point out on this one as well is that there are gaps, which we wouldn't have. So that's another negative of that model. The final one is known as the ball and stick model, or where we get a positive and then we get a line, and then we get a negative, then we get a line, then we get a positive, then we get a line. Okay, so it's good to show the arrangement of the ions, but the bad thing of that model is the sticks are meant to represent the electrostatic attraction or the forces, and actually that isn't what they're like. It's an invisible force, it's not a stick, it's not something physical that can be seen between each ion. So this model is probably the worst out of the lot. Okay. So that's it in terms of what they look like, what we expect, and models. So ionic compounds have two properties that you need to know about. Okay, within these properties, you need to be able to explain why. And they're really standard set answers. You'll get these repeating phrases come up quite a lot. I know that when I teach lots of different units, I repeat these phrases quite often because they're quite often worth 2 or 3 marks. If you learn them as they are, you tend to get those higher marks. So properties. Property number 1 is that ionic compounds or giant lattices have got high melting and boiling points. So that's a property, that's something that they have. The reason why is because they have lots of strong electrostatic attraction, or you could say that sentence I told you to learn. They have lots of electrostatic attraction, which is strong. That means that it requires lots of energy to overcome them, to break that electrostatic force between them. So if you think about 2 really, really strong magnets, you have to put a lot of force in to pull them apart. So if you think about 2 ions that are stuck together, like the magnets stuck together, you have to put a lot of energy in to pull them apart. So we say that they need high temperatures. If you remember energy, heat, thermal, so we say requires lots of energy to overcome them, which means we need lots of high temperature. So it means they're usually solids at room temperature. Okay, so high melting and boiling points because they've got lots of strong electrostatic attraction, which requires lots of energy to overcome them. If you learn that, that's worth 3 marks in an exam. Just that statement there. It doesn't matter if you don't completely understand it. If you can write that down, you've got those 3 marks. The second property that they've got is that it can conduct electricity. So the definition of current, which you will have learnt in year 8, but you will relearn when you revisit electricity at GCSE. So the definition of current is a flow of charge. Well, we know that ions are charged particles. So if the charged particles in an ionic compound can move around, then we can carry a current. So ionic compounds can conduct electricity when they are molten. That word means they're melted, so they're in a liquid form. So they can conduct electricity when they are molten or they're dissolved. And that's because the ions or the charged particles are free to move around. They can't in a solid because the ions are in fixed positions. I've seen 2 types of exam question here. One type of exam question asked why sodium chloride solution can conduct electricity, and the answer would be because the ions are free to move and carry charge. I have also seen on an exam question why can solid sodium chloride not conduct electricity, and it's because the ions are fixed and cannot move. So just be aware that they can ask the same question but word it differently. So just a small note on how we can increase the strength of the electrostatic attraction. So up here I've talked about how we've got high melting and boiling points. If we had, for example, sodium chloride, so sodium and chlorine, my apologies, that's a positive, that's a negative. They've only got a +1 or a -1. So if we compare it to magnesium and oxygen, where it's 2+ and 2-, because we've got a bigger charge, we've got a stronger we've got more electrostatic attraction. If we've got 3+ or 3-, we've got more electrostatic attraction. So I haven't seen this come up before, but it's just worth knowing that if we compare sodium chloride's melting point to magnesium oxide's melting point, this would be higher because we've got a higher charge on our ions. So the higher the charge on the ions, the stronger the electrostatic attraction. So if you had something where you had, these are the only options you could possibly have on this question. If it's in group 1 and group 7, and then you compare it to something that's in group 2 and group 6, it's got more electrostatic attraction. Right, today, as I say, just some exam questions. You've had quite a lot of work over the last few days. Thank you to everyone that has submitted their assignments. If you are still catching up on work, please make sure you are contacting your teachers just to let them know that you are getting the work and you are doing it. Any questions, drop your teachers an email, and speak to you all next week. Bye.